And this science off the sphere involves filling a balloon up with water and popping it, and what happens to it in a weightless environment. We're going to see this many times during this short video, so we'll be able to look at some of the physics. So there's the balloon, and I've got a little needle, and you pop it, and you can observe the behavior of the water without having gravitational effects make it just fall to the floor. So here we go again, and you pop this thing, the skin disappears really quick, and you're left with a pseudosphere of water that undulates around a little bit, and eventually surface tension forces will convert it into a sphere. Or no, this is a slow motion, so watch closely. So it goes pop, the skin disappears really, really quickly, and then two shock waves form as a result of the rubber skin peeling away, and they're on opposite ends of the balloon, and they come together in the middle and make it squeeze out kind of like a pancake. And then after that, surface tension forces will make the resultant water pull together in an undulating mass until it eventually forms a nice, pretty sphere. So again, here's a balloon. It gets popped. Notice the rubber peels away, and you're left with this water in the shape of what used to be the balloon. And then here you can see the two shock waves moving in towards the center, squeezing the water into a pancake-like structure. And then surface tension forces will pull on that pancake and make it into a potato, and then that potato oscillates around, and eventually you'll end up with a nice pretty sphere. And of course, you can't do this too many times. I mean, this is really neat. So here's yet one more example of what happens. And each one is a little different. And again, the skin peels away really quickly, and you're left with this unsupported shape of water, which on Earth would just fall to the ground under gravitational forces really quickly, and you won't be able to see the resultant behavior. Now, the balloons that I had here were kind of oval shaped or oblong. Well, I found one that was more spherical. So let's look what happens with something that's close to a sphere when the rubber balloon is removed. So here goes. So again, the skin peels away. You're left with this close to a sphere of water, unsupported. You see some ripples on the surface, and now you can see the two shock waves coming together and squeezing it into a pancake. And this is a really interesting example where a single point initiated shock wave will end up making two adjacent shock waves coming together in the middle and squeezing this into a pancake. Oh, and watch this. It formed this long column of water, and then the Rayleigh instability comes and breaks it up. If you have a column of water greater than pi times the diameter, it becomes unstable and it breaks up. So here's the final one shown in real speed. And I want to end this by saying that we did all of these in our hygiene area, and we had plenty of towels around. You can see after you release one of these spheres, you can easily capture that in a towel. And now you have a wet towel. You can use this towel for your hygiene break where you do your sponge bath.